Thank you, Chaoyu. So that concludes the papers of this session. Next, we'll have an expert panel with 5 very well-established data mining experts sharing their experience and vision for the field of data mining and knowledge discovery. I will introduce them in alphabetic order. So the first guest is Professor Wei Ding from University of Massachusetts, Boston. Hi, Professor.
Hello, good morning.
Hi, Professor. The second expert is Professor Xuemin from the University of New South Wales. Hi, Professor Lin.
Hello, good morning, everybody.
Good morning. The third expert is Professor Jian from Simon Fraser University. Hi, Professor Pei. Nice to meet you. The fourth expert is Professor Shashi Shekhar. Hi, Professor Shekhar.
Hi, everyone.
Good morning. The last expert is Professor Xifeng Jian from UC Santa Barbara. Professor Jian.
This is nice to meet you all online.
Nice to meet you. It's really nice to have an expert panel with so many well-established researchers in data mining. And today we will basically learn from you on what is your opinion on the most important research in the past 10 years in data mining, and what's your vision for the data mining research, let's say for the next 10 years, where we can move forward. So let's maybe let's answer the question who want to go first, or we can still using the previous order. Maybe Professor Ding, you can go first.
I'm sorry, my daughter was just in the room. Okay.
Oh, understand.
Okay. Heard sure. Your question. So could you repeat the question one more time?
Oh, so what will be what's your opinion about the most important data mining progress in the past 10 years, and what's your vision for the important data mining trend and research in the next 10 years?
So for today's talk, actually, I did some homework, and then I analyzed some data, things I'm currently working at NSF. So I think for these 2 questions, Dr. Pei Jian and Dr. Shashi Shekhar, which I have collaborated before, surely have much better answer. Okay, because they're quite well established. And then, so maybe I can just show some slides to just warm up the panel discussion, and then we can delay the questions for the other professors to answer those specific questions. So here is the thing I did from the. So can I share my screen?
Yes, I believe you can share. It's configured to be able to everyone can share. Thank you.
So let me make the presentation view. So this is what I have here. So I searched for the global database, and then using 3 different keywords. So we have machine learning, data mining, and deep learning. And then the things your question is about the last 10 years. So I searched, the starting year is 2012, and then the end year 2021, because we have not finished 2022 yet. So the data will be incomplete. So you can see that we have 3 columns. The first column is I search using keywords machine learning. And the second keyword I use was data mining. And third one is the deep learning. So it shows the number of publications. As long as you have the keywords in the title, in the abstract, and also in the paper body, then it will select this paper. You can see in the year 2012, you already see the data mining is already lag behind machine learning, and then you can see the deep learning. It is is below data mining and machine learning. But then after 10 years, you can clearly see the numbers. The ranks actually has been changed. So this is what we have here. So this is the same table, but I show the plots. And then the blue line, so at the beginning was behind the green line, but now it's leading ahead. So which is not surprisingly in machine learning. And then data mining, you can see at the beginning it has a strong start, but then gradually it's actually lag behind. And then we have the deep learning, it's kind of like in the parallel with the machine learning. It's kind of like show lots of research publications is in deep learning and then machine learning. And since machine learning is leading the effort in the knowledge discovery community, and then what I did for the next slides is I'm looking for, since you asked about the interesting application areas, right? So I look for the top 5 application areas. So you can see what we have here.
合同昨天晚上3点20分打印好的。
哦呦
，3点多打印好的，这是。
Oh, sorry, I just muted all, and Professor Ding, can you unmute? Yeah, I apologize.
Okay, so then this is the things machine learning is leading the effort in the knowledge discovery. So I'm interested to see the, so let's go back. So I'm interested to see what we have here. Okay, 1 second, so let me go back. Okay, since we were interrupted, maybe so we start from the second slide one more time. So we can see the machine learning apparently is leading the effort, right? So then I did another search. I'm looking for the machine learning research categories. And then the plots actually show the top 5. So from the global database. So we can see, no surprisingly, information and computer science leading the effort. So this is the most popular areas for the machine learning research category. And then for the second one is actually in AI and image processing. So you can see actually the most popular areas for machine learning is in image processing. And then we have the third and the fourth actually are quite close to each other. You can see the blue color is for engineering, and then the maroon color is for medical and health science. And then the last one is on the information systems. So this is kind of like related with your application areas for data mining and machine learning. So then for the next one, actually I'm interested to see the top 5 countries in machine learning publications. And then we can see here, so starting from 2012, 10 years ago, we can see the top one is United States, and the second one is China, and third one is United Kingdom, and then the purple is Germany, and then the last one is India. So 10 years later, you can see the ranking for the machine learning publications, the top 5 countries. So it's kind of like, so it's now changed. So we can see the China is now leading the effort. And then second is United States, and third is India, and then Germany is is the last one of the top 5, and United Kingdom is ranked the 4th. And then for the next slide, I show I'm interested to see, okay, for the machine learning global, so this is the global ranking. So I'm interested to see for the machine learning research organizations. So the top 5. So this is based on the publications. So here, this is what we can see here is we have 3 universities from China actually ranked on the top 5. And then in the United States, we have Harvard and Stanford. And then for the year 2021, we can see that the top 1 is actually from the University of, it's actually not university, it's Chinese Academy of Science. And then so this is very close between Tsinghua and Harvard. Then Shanghai Jiao Tong is ranked the 4th, and then the Stanford is actually ranked the 5th. So quite interesting result. And then what we have here is, so since we have the number of publications, and people like to argue, because this is the quantity, right? We want to see the quality of the publications. So in that case, citations and the mean number of citations often matter. So that is why I show the second and third column, we have the number of citations and the mean citations. And we can see, so this is a question for Dr. Da Yan. So which university actually has the highest citations, which really indicate the quality of the publications, right?
Mm-hmm.
Which one, based on the information I give here?
It's Started Harvard?
Harvard, right?
Yeah.
No, actually Stanford.
Sorry, Stanford. Sorry, yeah.
Stanford, the top, and Harvard ranked the second.
Second, yeah.
Yes, so even for Tsinghua University, the number of publications is larger. But then if you look at the citations, actually less than half of the number of citations compared to Stanford and Harvard. Okay, and then that's it. So this is the homework I did for today's presentation.
Thank you so much, Professor Ding, for the insightful slides. And okay, so let's move on. Maybe yeah. Go ahead.
Yeah, I think
Professor Pei.
Yes, I would like to ask Professor Pei to answer the two good questions.
Yeah, thank you very much for having me here. Thank you, Wei, for pointing to me. So I think it is very hard to say what is the most important progress in data mining as wealthy and robust area growing for 20 years. Probably the most significant accomplishment is that people now think data mining is an area, is a very well established area that not part of the databases, not part of the statistics, not part of the machine learning. Instead, people will think data mining itself is an area. The second thing is that many people, when they touch data, when they have real applications, they think about data mining as the tools they can seek for help. So to that extent, I think probably that's the most important accomplishment of us. Yeah. Yeah. Thank you.
Thank you, Professor Pei. So let's maybe move on to Professor Shekhar.
Okay, so let me give some counterpoint. So I don't know if any of you read the Science magazine today. Let me share the screen and show you what they are saying about deep learning, machine learning, and everything. Okay, so this is an article that came this week. I don't know how many of you read it. So it's basically saying that all the deep learning, machine learning things, they don't generalize well. Okay, so there are benchmarks. They can do well on the benchmark, ace the exam, and then you take it to the real field, and then they embarrass us. Right? So the great ImageNet from Stanford has a lot of citations, but I think many of them are very negative citations. So you don't want to just take each citation in the same way. Like this article is citing ImageNet from Stanford, but really saying very negative things about it, right? And it has been actually criticized all over the place. Look at New York Times, right? Face recognition software, which were trained on ImageNet, had a lot of bias, right? White male faces, they did well, but female faces, dark faces, they did poorly, right? So ImageNet was extremely poorly constructed, right? So most references to ImageNet, I think, are negative references, and we should not take them positively, right? Other things, like self-driving car, let me break that and show you, computer vision folks who are behind it. Again, a lot of hype about testing self-driving car in California, but look what happens in real life, okay? They don't tell you about weather impacts, right? And look at what happens when you take them to rainy season, right? I mean, they are tested in California and Arizona, which has no rain, but they don't bring it to Minnesota, right? We have snow and rain, and look how poor their sensors are, right? So I'll go to the next slide so you kind of get a sense of the limitations of these things. And these are becoming important if you want to have all these claims and say that their technology is great. then they need to be responsible. Look, computer vision only wants to mimic human vision, which is not that great. We can see a very narrow part of the spectrum, right? They could come to remote sensing and spatial data science, where we use much richer set of sensors, right? Infrared that you see in spy movie, microwave that can go through rain and water and many other things, right? So yeah, it's fine. You can count publication, you can count citation, but they don't really tell you much, So with this, let me actually kind of give you the positive news. I mean, certainly deep learning has generated a lot of excitement. It can mathematically, it can learn arbitrary functions, but its use in computer vision has a lot of problems, right? The out of sample generalization, we have no clue, right? There is the vacuous bounds on prediction error. So it has generated a lot of debate, but you really need to separate the wheat from chaff, okay? There are some good results in engineering. If you use it to solve differential equation, you can speed up over finite element. But a lot of other papers, I think, outside these conferences, you need to get out of the echo chamber or the bubble of AI and machine learning. You step out and you don't hear a lot of very good things about these things. The scientific rigor is lacking, and there are many more open questions than this community will let you believe, right? So yeah, deep learning is good, but a lot of questions, and we really need to solve them before we feel proud of this. And by the way, there is new trend called responsible computing. Okay, computer science is being used in all aspects of our lives. So when we make mistakes, the costs are very high, right? And the rest of the society is now looking at us and saying how those are not acceptable. Right? I mean, when Facebook ranks news and generates all the misinformation and polarizes the society, however many citations those algorithms have, that's not good for us, right? So we really need to start taking a broader look and go beyond citations and H index and number of papers to really see what the rest of society is expecting for us. So that's how I'll test to counterbalance this, And some of the data mining algorithms have same problem, Let me come and maybe show you one or two things like association rules, right? Spatial association rule paper, Jian, Jian, you actually know both sides. You have worked on collocation and you have worked on spatial association rule. But look at what spatial association rule with thousands of citation, what happens, If I have spatial data, suppose it's continuous space, red, blue, and yellow data, right? If you want to actually run, association rule, the result will depend on the partitioning. In this partitioning, you will say, red and blue are, co-located, but yellow is not. But if I change the partitioning, your results will flip. So this association rule, which has a lot of citations and papers, highly unstable for continuous space, right? And we never reveal that, right? Spatial association rule, thousands of citations and papers, and they never reveal this kind of a problem. But when you want to serious, real people to use it, these things matter, right? Same thing, DB scan. If you look at DB scan, if you throw some noise at DB scan, it will start giving you really spurious results. What happens to DB scan? This is complete spatial random, and DB scan is giving you dense, areas, right? Even if I put random, noise in the background, DB scan is giving me spurious things, right? So these are the things are okay if all you're doing is to choose advertisement on Facebook. The cost of false positive is low. But if you are using this to find disease clusters like COVID or crime hotspots or accident hotspots, all these false positives have very high cost, right? If you declare a neighborhood to be false hotspot of a disease, that has real costs, right? So we need to get out of our echo chamber. We are very happy in our conferences, counting papers, citations, and H index. But the rest of the world, when they look at us, I don't think, they are that happy about what we are doing. Right? So we need to become more responsible and take societal situation into account. So that's all, this is just to trigger discussion. Again, don't take it's too pessimistic, but just to have a balance. Yeah, we have papers, but rest of the world is complaining about our fragility of our technology.
Thank you, Shashi. This is really a very unique and interesting perspective, and really bring a lot of discussion for this panel. Maybe the next will be Professor Xifeng.
Okay, sure. It's my great pleasure to have this opportunity to talk about the history of the data mining and the future of the data mining. Certainly, I'm not able to comment broadly, but let me just show you some bigger progress that have been achieved in data mining in the past 20 years. One area I would like to comment is specifically is graph mining. So we started graph mining 20 years ago. And first we have the graph pattern, and then we have the graph management system using the graph pattern. And then we start to see graph embedding, graph neural network, etc. So I think the graph data mining becomes one of a very successful research field in data mining, and then grow to many different sub areas, including nowadays a very large area called knowledge graph. So this could be counted one of very successful area in data mining. The second one, like what Shashi has mentioned, that association rule mining. Association rule has been there for many years from like basket mining. But recently, we just wrote a paper to show that using association rule mining, you are able to outperform the performance of traditional graph neural networks. If you want to explain the mined result to users, you have to rely on design tree or association rules. You cannot deliver a very gigantic models to users. That's it, and this becomes a black model. You are not able to explain those output to the users, right? When we talk to the business users, they rely on rules and not on like a black box model. They want you to explain the result to them, why it is important. They need some actionable rules so that they can influence the business process. So I think this area will grow dramatically. In the past, we do not see many applications of association rules, but we will see it, especially when we use deep learning models to discover important patterns. We needed to convert those patterns to understandable rules and deliver those rules to the end users. And you will see this kind of application booming. And we wrote a paper called BERT RL, and it shows that it can actually perform the very state-of-the-art graph neural network method. Okay. And I would like to say that text mining also is one of very successful areas. Also nowadays, NLP becomes a huge area. But I saw that my advisor, Jian, has done fantastic work trying to find the text patterns in a large text repository. So this is another one successful area. And continue graph mining topic, and then you will see branches. Not only we see successful application in social network mining, we also see nowadays, you see that how can you use the graph neural network to generate chemical compound designs. And many of those works actually borrow idea from graph patterns, right? Basically, you try to find small graph patterns, assemble them together using graph neural networks, try to generate those chemical compounds with some specific constraint. And this area, I see it is booming because we really would like to use the data mining techniques, AI techniques, try to help develop next generation chemical compounds and drugs, etc. So I would like to say that the data mining actually is a very diverse area. Actually, you can see from our talks, right? It not only have database like expert try to scale up those basic operators. We also see the machine learning expert, data mining expert try to study this area from many different angles. So we do not confine ourselves in a specific, like using a specific method like neural networks. You can use association rules. You can use traditional combinatorial algorithms as long as you really solve customers' problems. So this area, I think, will be and will continue to be a very interesting and successful area in computer science. Just my personal observation for this area in the past 20 years. Thank you for giving this opportunity for me to talk about my opinion.
Thank you, Xifeng. And it's a very insightful trends, social mining and deep learning. So the insight is very interesting. And so Professor Xuemin, so could you share your opinion? Thank you.
Okay, thank you very much for giving me the opportunity to speak here. I'm not really a data mining person, right? But in the recent years, actually last 10 years or so, I have doing graph mining. So the previous expert actually said many things I fully concur. So I feel I have nothing to say, right? But still, let me say something. Continuing with Xifeng's graph mining vision, right? I think this area is growing very fast. And now, previous people more like focus on the efficiency, right? Especially database person focus on efficiency. Now people move on effectiveness as well. So I think this trend will be like continuing for the next few years. So we will see lots of things happen, right? Something like knowledge graph, and also in many application domain against terrorists, so on, so forth, right? So, yeah, okay. I conclude my speak, right? So I think it's time.
Thank you, Xuemin. So is there anyone else who want to ask any questions to the experts, or if anyone has any additional opinion, want to share and discuss in this panel?
I would like to ask Professor Ding, where the data from? It's so impressive.
So this is the tool I use at UNSW to access the global database for all the publications.
So all the application, including everything, or also very selective?
Including everything. I use the default selection. So I use the keyword search, so that has because then the several slides I focus on the machine learning, right? Once I found machine learning leading the effort, so this is the machine learning keywords used in title, abstract, and also the paper body.
I see. So when you talk about the number of publications, so on so forth, you compare with CS ranking. What's the difference?
So basically, I'm interested to see the number of publications. And of course, I agree with Professor Shekhar, citations cannot say everything, but it is one of the factors to indicate the quality. Even those are the negative comments, at least it shows people are interested in this paper. So then I think I focus on the keyword search on machine learning, and then the number of publications and number of citations. And then we can see I know currently machine learning is very popular in medical and health science. So I know for the United States, they put a lot of effort in the medical and health science. And also agree, Shashi talking about the AI fairness. So UNSW did create a new funding program for the AI, FAI. So it focused on the AI research in fairness. And also for I think Dr. Jian also had the questions about the opinion for the opportunities for the data mining community, right? I think currently UNSW is very interested in AI-enabled scientific discoveries. So that means they really want to have, I think that we realize the problem, you cannot just only apply machine learning algorithms on those well-trained data set. So it had to show some impact, societal impact on the real world applications. So we do start to focus on the AI-enabled scientific discoveries. So that means you really need to have the true collaborations with domain scientists and also with industry partners. So I think that the role for the industry collaborations and then the role for you to apply, not just deep learning. I think even in the NSF, we actually really constrain the number of proposals that to be funded only on deep learning, because there's so many nice diversified machine learning algorithms. So such as graph mining, associative rule mining. So deep mining should not just be the only one of those. Okay, so we cannot just only find the deep learning. So I think it's this. We like to have a really vibrant machine learning researchers. So focus on many different machine learning topics and areas. But we can clearly see China is making lots of progress in the last 10 years.
So I would like to say it is exciting to see the great growth of deep learning, really a very successful method. I do not think that there's a conflict between deep learning and data mining, right? So in our recent work, I just said that BERT-IL, we use deep learning method to find association rules. And usually, traditionally, like when you do the association rule mining, you will find millions of rules. But if you use deep learning to do that, you are able to automatically filter out many redundant rules so that you can just deliver the best rules to your customers. So I do not see they are competing with each other. I see that the data mining is a large area. We can take any kind of method as long as we are able to solve the problems from users. As Professor Ding said that, okay, if you want to do scientific discovery, you can use a deep learning method. You also can use a combinatorial algorithms. You can use a statistical method. You also can use associative rule mining. I mean, in the end, usually you are going to deliver some kind of rules, right? If you increase the temperature in some degree, the material you manufacture will achieve this kind of property. In the end, we need to deliver this kind of thing. We cannot say that we just fully rely on a deep learning model to deliver a result. I mean, at the very beginning, you don't have this huge amount of data available to come up with a reliable model. You have to rely on the domain experts' knowledge. So what are those knowledge? Those knowledges are rules, right? If we look at the medical treatment, these are rules, right? If the patient satisfies this constraint, you are going to apply this kind of treatment, right, etc. So I think we should be open and accept those methods and try to help this area to further grow.
And also, I think there's a new trend, very good points. And also, I see a new trend for the co-design of software and hardware for the AI research in the United States. So basically, when you design new machine learning algorithms, you have the correspondent hardware design to really incorporate your machine learning algorithms. So you can have extreme scalability for your machine learning algorithms. And also, so they want to have a full stack improvement of the machine learning algorithm, not just on the software side, it's also on the hardware side. So this is a new trend, co-design in software and hardware. So they really value multidisciplinary collaborations. Shashi?
So I wanted to go back to Xifeng's comments about deep learning and data mining. You can certainly treat them as competitors and so on, but there is one place they actually come together very nicely. So deep learning has been, if you remember, very successful in computer vision. So if you have to analyze imagery or video, I mean, that's really where it came to prominence. And that's an area where I mean, you can apply data mining, but you don't have to. You might as well let deep learning analyze the image and give you the objects. Okay? And once the objects are in hand, then you bring in data mining to find patterns in this object, right? So for example, if a lot of us are reading about the Ukraine situation, and all of us are realizing from satellite imagery, they were able to detect all the military vehicles, right? They could count the tanks and airplanes. And chances are that was done through deep learning with some human, right, post-processing. But once you find those, then you can say, okay, let's do pattern mining. If these, even if there are 1 million tanks, if they are sitting in a, without any soldiers, that's probably a junkyard, right? I mean, that's not interesting. But if you see soldiers and other protective vehicles, that kind of a pattern, you can call it association rule or collocation. But that's much more interesting in terms of the offensive or defensive maneuver, right? But we don't have to go and just redo, detection of tank from satellite imagery, which deep learning can do reasonably well, right? But we just build on that, let it detect the vehicles. And then we find the patterns, whether they are hotspots or collocation or something else.
So actually, I'm interested to see how, so I think Shashi pointed really interesting points. But then, Professor Pei, I know you always have very insightful, keen ideas in machine learning data mining. I'm interested to hear your comments and feedback.
Yeah, I agree with you all on different points, but I think for pattern mining, the most important thing is not one algorithm or two that we should use. Instead, is the idea or the methodology of pattern mining. When you have a large amount of data, complex data, you try to find patterns. And what really patterns are those things, maybe frequent, maybe some kind of other interesting bits. And this methodology has been well established and accepted by many people. However, how to find such patterns is a different story, and you can use many different tools to do that. I mean, today you may use deep learning, and tomorrow we may use the human being AI to do that. I mean, it doesn't really matter. And then you can also extend that to, for example, causality, and you also want to know not only the patterns you observe, but also what are the factors driving those patterns. And then my understanding is that for data mining, it is different from machine learning in the sense that we are more looking at end-to-end data analytics. And we are focusing more on how to derive knowledge from data. When we say derive knowledge from data, I personally feel the most important thing is communication. Communication between the data owners, the data users, and also the domain experts. That is a part really data mining or KDD has the value. Yeah, Shashi, that I agree with you that indeed there are many things we do not really need to focus on the technique, and also Xifeng mentioned that. Yeah.
Yeah, thank you. And I also think it's very interesting for the Xifeng's finding, right? So for the associative rule mining, it's like frequent pattern mining, different kind of patterns, and a lot of other like graph patterns. I think my experience is that we like the research we found that there's overwhelmingly many patterns if we need to tune the parameters. Right? I think deep learning could be like acting as a tool to guide us which of those results are useful, right? So I'm not in that area of like there's a skyline query, but I recall that there's like a regret minimization. Previously, people find the skyline, which is overwhelmingly many, and then people find a way to minimize the query set, result set, and then find the really useful things. I think, for example, for deep learning, there's some feedback, right? Like supervision, you have some metrics, right? Well, for a lot of the pattern mining, we need to define some patterns a priori, and I think they are useful. And then people are just finding efficient algorithms to tackle them, right? So I think fundamentally they are kind of different. But they can work together, like using deep learning to improve data mining. Yeah, and we also recently work on are working on the collocation pattern mining. I think Shashi initiated this problem in the field, right? So we found actually interestingly, it's quite similar to the graph matching problem. If you look at everyone within certain distance, right? If you connect an edge, it's actually mining the frequent subgraphs, right, from big graph data, and this can elegantly actually remove the boundary of the space discontinuity if you cut the space. I think that's kind of
key is to use neighbor graph, not partition it like spatial association rule. I mean, Jian Fei got involved in this also very early with Yan Huang and so on. Yeah, but neighbor graph, you can pose it as a graph mining problem, but computationally graph mining is more expensive than collocation.
Yeah, actually, like language models, n-grams are all kind of association rule mining. Instead of explicitly enumerating all of the association rules, it's implicitly encode those rules in the network. And given the few words, you would like to generate the next word, predict the next word. It's very close to association rule mining, right? You have the basket of the products and what's the next product you are going to buy. very close. In data mining, we just didn't recognize that we can do it implicitly. In deep learning, using embedding method, you can do it implicitly. So that's the difference. And certainly in the end, you will, if you want to use those things in a high level, you need to generate the rules so that we can apply it. But otherwise, how can I transform the entire network into a decision-making process? You have to make a decision. The decision usually, like especially in the business intelligence in medical domains, is a discrete event, and you need to translate, extract it from the continuous model to discrete rules, etc. So I also forgot one area I think that's very unique in data mining is temporal spatial data mining. I think this is a big area in data mining, like the smart city, like the atmosphere, this kind of modeling. I see a lot of researchers grow from the data mining area and contribute significantly to this large domain. And now because of the global warming, it becomes more and more important to using data mining techniques. And together with all these kind of techniques to solve it. And we needn't to differentiate who invented who, we just want to solve it. And the data mining could be a great playground to accept those publications in this area.
Right. So I'm glad you brought up climate change because that's a big societal challenge, and I hope this community gets more involved. But once you go there, then you do have to worry about this out of sample prediction, because climate change, in some sense, is a non-stationary phenomena, right? It's saying past is different than future, right? Future will be different than past, and if that's the case, then question is, data mining, machine learning, statistics, deep learning, whatever you call it, can they really handle non-stationarity?
Yeah, very interesting. So I think the social responsibility is like a very important perspective, and for like with data mining researchers, and also like a data bias in ImageNet and those data set. And it's very interesting to see Dr. Ding share that like image processing, right? Image deep learning is kind of one of the biggest area. But I think it's no surprise because the deep learning starts from the image domain. Right? So I think Xifeng has a lot of experience in like NLP, right? So maybe what is your opinion about the NLP domain in terms of deep learning and data mining?
Yeah, certainly in NLP domains, there's a breakthrough brought by GPT-3, this kind of transformer-based model. And transformer can not only can be applied for solving NLP problem, it can also be applied to solving time series problem. And we have systematically show that. And currently, the newest paper shows that those large models can help us to solve those grade 3 or grade 4 elementary school math word problem. It's very amazing. Not only they can make it like logical correctly, but they also can generate grammar correct sentences. There's huge opportunities in NLP. On the other hand, I think text mining should be a very important area for data mining because of the free available data. So the reason why we do the natural language processing text mining, part reason is we can get those free data online, right? In the past, I'm very interested in social network mining, but I found that it's very difficult to get social network data due to the privacy. But the text data is everywhere, so you can mine those knowledge graph from the text, and the knowledge graph will become a very important area because in the end, if you solve the language problem, the remaining problem is about the knowledge, right? How can you represent the knowledge and couple the knowledge together with language model so that you can generate knowledge grounded natural language text. And after that, you will see reasoning. So I see the convergence between language model, knowledge representation, and the reasoning. And when you have these three, you are able to build a quite intelligent system. I feel that all researchers in AI, in data mining, in machine learning should look at those problems so that you could have a collective power. Instead of just rely on language model, you also can rely on the knowledge representation and the reasoning and even first-order logic, and together, first-order logic mainly is about the rules, right? You have rules and you have the fact, and use those rules. how can you generate as a new fact, like the mathematical pruning. It's a kind of rules. You have a bunch of rules, axioms, and you have some basic facts. How can you generate the entire mathematical systems? So if you can combine those things together, you will see the real power of an intelligent system. I think this is definitely an area that we should pay attention to. But thank you for raising this question.
So thanks for the discussions. I guess we are about time to start the next